this video, we are going to study how to calculate the geometric mean. The geometric mean is a mathematical average, and if there are n values in a series, then their geometric mean is the nth root of the product of those n values. Now let us see the formula to find the geometric mean in individual series, discrete series and continuous series. The formula to find geometric mean in the individual series is geometric mean is equal to antilog of sigma log x by n. And in discrete series and continuous series, the formula becomes antilog of sigma f into log x divided by n. And now let us study the calculation of geometric mean in the individual series. Suppose the x values are given like this. We have to find the log of x. That means for each of these values using the logarithm table, we have to find the logarithm values. And then all these have to be totaled up. When we are adding it up, we get sigma log x. Here it is 9.2101. And then we can apply the formula. Geometric mean is equal to antilog of sigma log x divided by n. So that will be antilog of 9.2101 divided by 5. Here there are 5 x values. That is why we are taking n as 5. Now when we find the antilog of 1.84202, we get the geometric mean as 69.51. Now coming to the calculation of geometric mean in the discrete series, the x values are given and the frequencies are also given. And the total of frequencies is 10. 2 plus 3 plus 4 plus 1. That is 10. This is the n. Then what we have to do is find the log x. That is find the logarithmic values of all these values of x. That is put here as log x. Now we have to multiply this frequency with the corresponding log x. F into log x. 2 into 0.6990 is 1.3980. In the same manner, all these frequencies have to be multiplied with the corresponding log x values and then add these f into log x to get sigma f into log x. Here it is 9.1865 and then apply the formula. Geometric mean is equal to antilog of sigma f into log x divided by n. By applying these values in the formula, we get it as antilog of 9.1865 divided by 10. That is antilog of 0.91865 and the geometric mean is 8.292. Next is continuous series. In the case of continuous series, the x values will be a continuous series of data. Here the x values are given as 100 to 104, 105 to 109, like that. Now our next step is finding the mid value. That is, for each class interval, we have to find the mid value. Then the frequencies will be given in the question. And what we have to do next is find log x. Here for finding log x, we have to consider these mid values. For each of these values, we have to find the corresponding logarithmic values. And that is put in this column as log x. Then the next step is multiplying this frequency with log x. Thus, each frequency is multiplied with the corresponding log x and we get this column. Then we have to sum up all these values in f into log x column. And here it is 1049.5584. Another thing that we need to be applied in the formula is sigma f or the n. Here it is 502. Now let us take the formula and apply these values in the formula. It becomes antilog of 1049.5584 divided by 502. That is antilog of 2.0908. Hence the geometric mean here is 123.2. Next, let us check the merits of geometric mean. The most important merit is that it is based on all the observations of the series. It is rigidly defined and not affected by the extreme values. It is capable of algebraic treatment. These are the merits of the geometric mean. Similar to all other concepts, the geometric mean also has got its own demerits. Let us check out the demerits of geometric mean. It is difficult to understand as we are using the logarithmic tables, that is the logarithmic values and the anti-logarithm and all. Hence, it is difficult to understand. And it cannot be computed when there are positive and negative values in the series of data given. It can also not be computed when one or more of the values is 0. So these are the major demerits of the geometric mean. So that's all about geometric mean. Thank you for watching this video. For more videos, subscribe the channel.